All right, let's get right into it. We're going to talk about something that is so often missed when you're first learning to code. But honestly, it's the secret to really, truly growing as a developer. We're talking about the principles behind the programming languages themselves.
You know how it is when you're starting out. You're just slammed with this wall of choices, right? Python, Java, C++, JavaScript, the list just keeps going. And it's totally normal to feel a little overwhelmed by it all. You're left wondering, which one is the right one? Where do I even begin?
But here's the thing. Here's the secret that changes the whole game. It's not really about which specific language you pick. It's about understanding the core ideas, the fundamental principles that they're all built on.
See, knowing these principles, well, that's what separates someone who can just follow instructions and memorize commands from someone who actually understands software engineering. It's the path you take to go from just being a coder to becoming a real engineer.
So why does this matter so much? Well, for starters, once you get these principles, you can learn any new language way, way faster. Your brain just starts seeing the patterns. You see how they're all just different takes on the same core ideas. You also start to get why they were built a certain way. And this leads to the biggest shift of all. You stop asking which language is the best, and you start asking the much smarter question, which language is the best tool for this specific problem I'm trying to solve?
Okay, so let's start with the absolute bedrock of it all, the difference between how code is written versus what it actually means. We're talking about syntax and semantics.
So, syntax, just think of it as the grammar of the language. These are the super strict rules about how the code has to be arranged. You misplace one single semicolon, and boom, the whole thing can break. The computer is probably the strictest proofreader you will ever meet. Semantics, on the other hand, is the meaning behind all that grammar. It's what you're actually telling the computer to do. So if you write something like x equals 5 plus 3, the syntax is the structure, but the semantics is the instruction. Hey computer, add 5 and 3 together and store that result, which is 8, in a box labeled x.
And this is a perfect example of what I'm talking about. Look how different languages can have the same meaning, the same semantics, but totally different syntax. Python on the left uses indentation, that clean, spaced-in look, to group code together. C++, on the other hand, uses curly braces and semicolons. It's a completely different look, but the meaning is exactly the same. Hey, all this stuff belongs together.
Okay, so we've looked at the nitty-gritty rules. Now let's zoom out. Let's start thinking about the big picture. We're moving from grammar to the grand ideas that shape how we even approach problems in the first place. This is all about paradigms and abstraction.
So what on earth is a programming paradigm? It sounds complicated, but it's not. It's just a style of programming, a way of thinking. It's a lens through which you look at a problem to figure out how to solve it with code. And there are a bunch of these different styles. Imperative programming, for example, is like writing a recipe. You give the computer a list of commands to do step by step. Object-oriented, which you see in Java, is about modeling the world as a bunch of objects that have their own data and behaviors. Then there's functional programming, which treats everything like a big math equation. Knowing these different approaches gives you a whole bunch of different tools to tackle any problem that comes your way.
Now for the next huge concept, abstraction. And honestly, this quote just nails it. Abstraction is all about hiding the messy, unnecessary details. You can drive a car perfectly fine without knowing a single thing about internal combustion. You just need to know how to use the steering wheel and the pedals. That's abstraction in the real world.
And in programming, we use layers of abstraction all the time. We're basically standing on the shoulders of giants. Way down at the bottom, you've got the actual hardware, the circuits and wires, then a low-level language that can talk to that hardware. Then, a layer up, you have high-level languages like Python that make things so much easier for us humans. And then on top of that, you have frameworks and libraries that let us build amazing things without reinventing the wheel. Each layer lets us forget about the complexities below it.
So, when you put all these ideas together, you realize something really important. Designing a programming language isn't about finding one perfect way to do things. Nope. It's actually a series of very deliberate choices and compromises. We call these the great trade-offs. And this is where the engineering really comes into play.
A classic example of a trade-off is efficiency versus readability. On one hand, you have a language like C. It's built for raw performance and giving you total control. It's incredibly fast because it's running super close to the metal. But on the other hand, you have Python. Its main focus is simplicity. The code reads almost like plain English. This means you can build things a lot faster, even if the program itself doesn't execute quite as fast as C. It's a choice.
All right, let's talk about the next big trade-off that every language designer has to wrestle with. It all comes down to something called type systems.
Now, this is all about how a language deals with different kinds of data, like numbers or text. And it creates this fundamental choice between safety and flexibility. With static typing, like in Java or C++, you have to declare what kind of data your variable will hold right from the start. It's like having a strict blueprint. It might feel rigid, but it catches a ton of potential errors before you even run your code. Dynamic typing, which you'll find in Python and JavaScript, is way more flexible. You just create a variable and the language figures out the type on the fly. It's much faster to write, but sometimes you can run into weird bugs later on. It's another trade-off.
So, what does this all mean for you? How does knowing about syntax, paradigms, and all these trade-offs actually help you get better at coding? Well, this is your path forward. This is how you level up.
First, you've got to understand that programming languages are living, breathing tools. They're not carved in stone. Python, Java, JavaScript, they were all invented to solve the big problems of their day. And they've evolved like crazy since then to tackle brand new challenges, from powering AI to running pretty much the entire modern web.
And that right there is the real magic. When you understand the principles underneath it all, you're not locked into just one language or one way of doing things. You become adaptable. You're ready to pick up whatever new tools come along in the future, instead of getting left behind, stuck in the past. So if there's one thing you take away from this, let it be this. Don't just get stuck memorizing syntax. Go deeper. Really try to understand the principles, because that is how you make the leap from being just a coder to becoming a true software engineer.
And that really brings us to the end. The question I want to leave you with is this. Now that you know about these concepts, which principle are you going to dive into next? Whether it's paradigms or type systems or abstraction, what's the next step on your journey?